This week, the workbook problems we chose are trinomials, which don't have exactly that standard form we're looking for. So if you'll remember from the lecture videos, we're expecting a trinomial to have a form that looks like ax squared plus bx plus c. Right? And that's all the examples that we saw in those videos. But it turns out we can get a little farther away from that form and still be able to utilize that same method. So for instance, here we've pulled out problem 2 part P. So you'll notice instead of an x squared and an x, we actually have an m to the fourth and an m squared. But we want to treat them that same way, right? We could maybe consider like our variable, instead of being m, our variable could be m squared. And then we have just that term squared at the beginning, and that term not squared in that middle term. But when it comes to actually solving the problem, right, we just want to think through that process the same exact way. So I'm going to do a times c, right, 1 times 24. I'm going to look at all the things that multiply to 24 and add to 14. So things that multiply to 24, I've got 1 and 24, got negative 1 and negative 24, got 2 and 12, I've got negative 2 and negative 12, got 3 and 8, negative 3 and negative 8, and I've got 4 and 6, and negative 4 and negative 6. So I'm trying to get to that positive 14, so I'll actually just look at all these positive pairs that I have. It looks like the pair that's going to add up to 14 is that 2 and 12. Alright, so again, we want to treat it the same way we would those other problems. We're just going to replace that center term. So I'm going to have an m to the fourth plus 2m squared plus 12m squared plus 24, right? All I've done is I've split up that 14m squared. And if I simplified this, I'd get back to that 14m squared. Now that I've got 4 terms, I can move ahead with that factoring by grouping. Right? So if I group these first 2 terms together, they have an m squared in common, so I'll pull that out. And I'll be left with, using those rules of exponents, an m squared plus 2. The second 2 terms, it looks like I can just pull out a 12, and I'll be left again with that m squared plus 2. Right? It still gave us that really nice factoring by grouping. And then to finish off, I'll pull out that m squared plus 2. I'll be left with an m squared plus 12. Now when I get to here, remember that last video from the lectures, we always want to ask ourselves, is there anything else I can do with either of these terms? So look at both of them. Is the GCF greater than 1? In this case, it's not. And since each of them have 2 terms, I'm going to look at it and ask, can I do difference of squares? Since both of these are sums, we definitely can't be doing that difference of squares. So I'm definitely done with this problem. All right, the other problem we picked out to work on this week is going to be part E of problem 2. So now we're actually getting even farther away from that standard form, that ax squared plus bx plus c. We've in fact added 2 variables now to our problem. So now we've got that y squared plus 8yz plus 15z squared. But just like in the previous problem, we actually want to keep moving forward with it with that same type of method, right? Because it didn't matter exactly like if it was an x squared and an x or exactly what the form was. It just mattered that we're trying to get 2 terms that are going to play nice when I'm doing that factoring by grouping. So let's go ahead and look for a pair of numbers that multiplies to 15 and adds to 8. Right? So with 15, I actually have even less options than I had in that last problem. So I can do positive 1 and positive 15, negative 1 and negative 15, positive 3 and positive 5, and negative 3 and negative 5. All right, so the ones that are going to add to 8 are going to be that positive 3 and 5 there. So again, replacing that middle term, I'll have that y squared, I'll add a 3yz, I'll add a 5yz, and I'll add a 15z squared. Right? Again, just keeping whatever variable part I had in that middle term, because all I've done is I've split that 8yz apart into 2 separate terms. They're still equal to 8yz. Okay, now that I've got 4 terms, moving forward with that factoring by grouping. So with those first 2 terms together, it looks like I can pull out a y. I'll be left with a y plus 3z. With those second 2 terms there, looks like I can pull out a whole 5z. And I'll be left again with y plus 3z. And then that last step, pull out that y plus 3z. I'm left with a y plus 5z. Then we go through, ask ourselves those same questions about GCF and if we can use either of our methods. In this case, right, none of our methods or GCF tools are going to apply, so we're done factoring this problem. So even though the problem might look a little scary when you first approach it, still try and fall back on that AC method even though you've got kind of those weird variables flying around.